means you have to use both of the special right triangles to be able to solve the missing side length. Now, someone brought up earlier, asked a question about, well, am I solving for that value of x like I would, what is the value of x in the 30, 60, 90, or 45? No, that's the specific side they're asking you to solve for. You'll use both of these things to get there, though, all right? And I'll show you what that means. In this example, you have a 30, 60, 90 triangle, and you know opposite which side length? The 60, good. So knowing that you have across from the 60, we start out the problem with, well, our 30, 60, 90. Well, we know that the x root 3 side is equal to what? 9. So don't worry about yesterday's homework. Let's worry about drawing what we're doing right now. And then how do you solve that one-step equation? How do you undo multiply? Divide. And you just divide, just like you did yesterday. Now, again, your calculator will do this for you. If you take 9 divided by the square root of 3, you get 3 root 3, right? So that's what's the value of x is for the 30, 60, 90. Which means across from the 30 would be 3 root 3. Across from the 90 would be 2 times 3 root 3. Which of those two values do I need to get to the 45 triangle? The 90. Because they share that hypotenuse. So I know if I put this in my calculator, I get 6 root 3. Which now becomes a hypotenuse of a 45, 45, 90 triangle. So now you have another side length to reuse. You're going to use one triangle to bounce into the next. And that's how these things are going to set themselves up. Excuse me. When I do the next one, we have a 45, 45, 90, something, something, something root 2. And now in that triangle, we know opposite the 90 again. So I set up this simple equation. X root 2 equals 6 root 3. And once again, it's a one-step equation. How do you undo multiply? Divide. And lo and behold, the main reason why I keep telling you guys that we needed to buy that calculator, I believe you should get, is it 3 root 6? You get 3 root 6 now for the value of x, which means across from the 45 is 3 root 6. You're basically just doing two problems in one diagram. That's really all it is. You're doing two problems out of one diagram. So now the missing side length, the one they're asking you to find, is going to be 3 root 6. Okay? Yes, ma'am?
Do you always have to start with 30, 60, 90 first and then?
It depends on the problem. Sometimes you're given that, sometimes you're given 45s. You can be given any one of those two triangles and any one of those angles. So you have 1 out of 6 to start with and just work your way out.
Okay.
It just depends on the diagram. Okay. Yes, sir. It depends on the problem. Sometimes you'll know across from the 45. Sometimes you'll know across from the 30. You don't have to divide, do you? It depends on the problem. That's why we constantly write this out to know what do you have. If I have it across one of these, yes, I have to divide. If I have it across from this one, yes, I have to divide. So basically, half the time you're dividing, The other half, you're not. But it's, what do you know? And that's why we write this out over and over and over. Okay. So we start this one here. Oh, I'm sorry, I get ahead of you guys. If I start this one up, we have a 45, 45, 90, and a 30, 60, 90. And we know across from a 45. So you start with your model. So I know that in my diagram, I have something across from the 45-degree angle, and that value is 10 root 3. Now this is a case that I don't have to do anything to it, because that is that value of x. If you start looking at it, you need to get to this part here to be able to bounce into the second triangle. Well, that means that if this is the value of x, I need to take 10 root 3 and multiply it by root 2 to get across from the 90. When you do that, you get
10 root 6.
10 root 6, very good. And now you're in a second triangle. Now you're in the 30, 60, 90 triangle. Excuse me. In that 30, 60, 90 triangle, you now know opposite which side length, or excuse me, across from which angle? 30. I know that opposite my 30 is equal to 10 root 6, which means that is the value. I don't have to multiply, I don't have to divide. And I'm trying to figure out what it is across from the 90. So if you double 10 root 6, what do you think you get? Well, that's 2 times 10. You're done. You pick a spot that you know. You figure out what your multiplier is, and you work your way through it. There is really no wishy-washiness. That's a word. There's no ambiguity. There's no weirdness. What's wrong, Ms. Toll? I heard you say what? Oh, do I even need to know it? I don't, because in this case, whenever I give you guys one of these composite ones, I'm just going to ask you to find one specific missing side line, and I'll just put an X there. Okay? You don't have to go through and find all the side lines, unless I ask you find all the side lines. But I know for a fact tomorrow I'm just going to ask you to find the one. Very similar to this. Okay? If I did find the 60, I would just take the 10 root 6 times root 3, and the calculator would do the work for me, and I'll get 30 root 2. I think that's right. Because it'd be 10 root 18, or sorry, yeah, 10 root 18. Square root 18 is 3 root 2. Yeah, so it'd be 30 root 2. But it didn't ask you that, so it doesn't matter. Take a minute. Set what that if I can speak. Sorry. Take a minute, set this one up on your own. And go for it. You start in a 45. Have you guys figured out the reason why I use arrows?
No.
what is it looking at? The 90 is looking at 9. That's the reason why I use arrows, because that's what it's looking towards. So it's looking towards some value, some value, some value times the root 2. Well, that value happens to equal 9. Now, what do you do to get x by itself? This is where you divide. Very good. When you divide both sides by the square root of 2, you get the side length to equal 9 root 2 over 2. Why? Because that's what the calculator just said. It's convenient that that's what it does. Now that's opposite A. Yes, ma'am.
So now, when you, for the 45, 45, 90, when you figure out what 90 is, you use what you got for x?
Mm-hmm.
Okay.
Yep, just like you did yesterday. This is that value x, so that means that's what would go across from the 45. Then you switch gears to the other one. Well, in that 30, 60, 90 triangle, you know what's across from the 30. So that equals 9 root 2 over 2. It wants you to figure out what's across from the 60. So I just substitute in for x, 9 root 2 over 2 times root 3, and I get 9 root 6 over 2. Yes, sir?
Why would it be over 2?
When I got this value of x up here, we divided 9 by the root 2. The calculator does what's called rationalizing the denominator. Basically, that means it gets rid of all imaginary, all irrational values in the denominator by multiplying the top and bottom by what's called a factor of 1. Because the square root of 2 divided by the square root of 2 is just 1.
When I put in 9 divided by the square root of 2, it just gives me 9 square root of 2.
You might have done times by mistake. Oh, here you've multiplied by 2. That's
Yeah,
why.
no, I was just looking at 2 times.
Oh, you know why? Because we didn't need to. We weren't worried about that side line.
Oh, yeah.
If we were trying to find that, you're right. Then it would be 9 root 2. You're correct. But here, I'm just trying to figure out the side length opposite the.
No, I know what I did. Yeah, so I multiplied 9 by the square root of 2 instead of divided by the square root of 2. There you go.
Keep writing them out. It's a simple thing to screw up. So again, this isn't really scary. It's just that you have to take your time to build it through. Okay? You just got to take your time to build it through. Excuse me. Give it a shot.
Wait, is the next one 30?
It is, because all you're doing is taking 10 root 3 times the square root of 3, you get 30. So now, that's across from a what? Is it done with the classes?
Unless you want us to write the X. Like the X and then like
My classes, so we're
X and then something.
Guys, how about a little enthusiasm for our friendship? Seriously, that's all this is. Hey, guys, this is all there is to this. As I want you guys to understand, as we build further and further throughout the second semester, these basic problems of 30, 60s and the 45, 45, 90 triangles, they continually show up time and time and time again. Same as Pythagorean theorem, it doesn't go away. And then on Friday, when we start talking, Friday and Monday especially, when we start talking about trigonometry, that's another thing that we'll utilize over and over and over again. But it will take us, I take a lot of time to get you guys through that, so we get a really strong background in it. So as we get into the more complex looking things, it's easier. Okay. Did I tell you what we're doing on Tuesday yet?
No.
We're having a field trip on Tuesday. No. We're gonna go to the auditorium. I know, it's exciting. Have you guys ever seen, well, I know you have, you know the people when they're on the side of the road, you got the tripods, they're looking through the machines, there's a guy holding a stick. They're surveying, the surveying crews. All they're doing with those machines is they're measuring distances via trigonometry. They're measuring distances bounced off lasers and stuff like that, and it's measuring angles of elevation, angles of depression within given degree measure. We can actually do the same thing given a protractor, a piece of string, and a paper clip. I'm not kidding. We're using what's called a clinometer, and it was one of the ways that they used to measure angles towards the stars, how they used to navigate at sea. It's a tried and true method of measuring distances that they've used for centuries. And myself and Severino downstairs, he and I made up this activity when we were in college 12 years ago, whatever it was. And we've been using this same activity in our geometry classes ever since then. We've had a lot of fun with this over the past 12 years doing this thing. And pretty much every kid that's done it's like, oh, this is kind of cool. So there's actual practical use for math. Believe it or not, I know it's hard to believe. I know, you're laughing. But what I want you guys to work on tonight is in the book. It's these 9 problems. And if you give me, let everybody write that down. I have it on the next slide, so you guys can take a picture of it real quick if you'd like. Okay. It's a mixture of the regular styles, find the missing side lengths, as well as there's a couple of composite ones where you have to use it twice. Okay. Don't forget, when we do our quiz tomorrow, you have to remember how to tell what type of triangle it is. If it's an acute or obtuse, that was easy. Go back and look at it. Excuse me. Questions on what we are at today? All right. Bowling. So I just have them on the next page so you guys can see them.